says to graph these parabolas, but these are kind of strange. And you got to remember, one of the most important ordered pairs in a parabola is the vertex, because often or not, the vertex tells us if this parabola has a maximum or minimum value. In this case, why don't we take a look at these one at a time? Let's call this example A, and let's call this example B. This one here, if you complete the square, you would try to extract the vertex. So you have an x squared here minus 10x. Then we write a parenthesis here. I'm actually going to move the y's and the other constant over here. And that'll be a little bit easier to see. Now I could balance the equation. So remember, in completing the square, you divide this 10 by 2, you get 5. Square it. If you square it, you're going to add 50 to one side of the equation. That means you're going to have to add 50 to the other side of the equation. Now you just react to this problem. React to it. 2 times the quantity, x minus 5 squared. That's why we completed the square. It is now equal to what? Y minus 3. And this looks like the definition of a parabola. So we could find our vertex. Our vertex, well, it actually says the graph, so it doesn't have to say that we have to identify. So why don't we put our vertex in a t-chart? X, Y, we have 5, we have negative 3. And this parabola is opening up. It's actually opening in the up direction. So it's very likely that it has a y-intercept. So why don't we look for the y-intercept? If we look for the y-intercept, that means that's when x is 0. So let's say 2 times negative 5 squared is equal to y minus 3. What happened to my square? Let's fix that there. Ooh, let's try that again. Squared is equal to y minus 3. So 50 plus 3, 53. So when x is 0, we get 53. And I'm going to draw a rough sketch of this rather quickly. Where's the vertex? 5, negative 3. I'm going to draw a graph that's not to scale. I'm going to make sure of that. 5, negative 3. 1, 2, 3, 4, 5, negative 3. So let's say here. That's 5, negative 3. We have when x is 0, it's there. So this is 0, 53. This is, this ordered pair was 5, negative 3. We need another symmetric point over here. So we have an axis of symmetry. This axis of symmetry is a horizontal line. In fact, it's called y equals negative 3. That's how we label horizontal lines. You have to write an equation. That equation is called y equals negative 3. And we just need to label this third ordered pair here. Well, I know it is, well, stop it. What happened here? I'm going crazy. Why didn't any of you guys stop me? Let's try this again. I said this parabola is opening up or down. Why are you letting me opening it to the right? Let's try it this way. I'll draw it not to scale this way. So 5, negative 3 is over here. This time over here. That's much better. And this is 5, negative 3. Now I have an axis of symmetry that's vertical. So we have to label a vertical line. How do we label this vertical line? X equals 5. So there's our axis of symmetry. X equals 5. I just need one more ordered pair. It's going to be over here. That ordered pair is going to be called, I'm sorry, not 10, 53. simply by counting. And play connect the dots, and you get a parabola opening up, and this actually has a minimum value in the y direction. You could do a similar thing for part B. The key is completing the square. This time we're going to complete the square on the y values. I'll use this color instead. Y squared minus 4y, leave a space, is now equal to x minus 12. Minus 12. If you complete the square, you're going to add 8 to both sides. You're going to add 8 to both sides. There you go. Why do you complete the square? So you get a very, very nice perfect square trinomial. Y minus 2 quantity squared is equal to x minus 4. Once again, label your vertex. Label your vertex. Your vertex is what? H, comma, K. So it's 4 and then 2. And this one's opening to the right. This parabola is going to open to the right. 4, comma 2. So that means there's very likely going to be an x-intercept. So x-intercept is when y is 0. When y is 0. So 2 times negative 2 squared is equal to x minus 4. 12. X is equal to 12. So when y is 0, x is 12. Let's start graphing this now. Opening to the right, 4, 2. There are no y-intercepts. That's a good observation to have. I'm also once again going to draw this not to scale. So 4, comma 2, right about here, let's call the vertex there. Our x-intercept is x-intercept is 12, 0. And so we have an axis of symmetry. This time this axis of symmetry is labeled as a horizontal line, so y equals 2. And we need this symmetric point up here. What is it? What is it? What is it? Well, I know it's 12 units to the right. So how many units high? It's got to be 4. And then we play connect the dots. Boom. This parabola has a minimum value relative to the x direction. By the way, this is not a function. How about the previous one? This one is, yes, this one is a function. And there you go, you've graphed a parabola. But at least 3 ordered pairs. It'd be nice to put them in a t-chart, or you could label them on your graph. Make sure you draw your own graphs. Draw, 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 draw. That is the mathematical skill that you're trying to learn here. And then, of course, label, label, label. So you want to draw, 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 then label, 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 and label.